So we are going to be learning two new formulas that we can use to find area of triangles when we cannot, it's impossible to find the height. Now, one of these triangles, one of these formulas makes perfect sense why it's in this unit because it does have a trig function in it. However, the other formula does not have any trig in it. So like in my head, it doesn't make sense why it's in this unit. But I kind of get it because they're like, oh, you're finding area one time, might as well just keep finding area one more time. Even though it doesn't really have trig in it, it can still be applied here because I guess we're finding area. So I apologize for that because it doesn't quite make sense where it's fitting. But this first one totally makes sense why it's in this unit because there is trig in it. So here, when I'm looking at this triangle that they have drawn here beautifully for us here, right under area of triangles, I have a B, which is my base, and I have my height, which is that dotted line. Originally, previously in geometry, how were you told to find area of a triangle? What was that formula? Yes, 1/2. No, it's not called that. That is area of a triangle. 1/2 base times height. 1/2 the base of the triangle times the height of the triangle. And it makes sense because if it was just base times height, that would be finding the area of, and don't draw it, but it would be finding the area of that full rectangle. But it's not the full rectangle, it's actually completely half of that rectangle. However, you guys may have noticed it is not always possible to find the height. So what we're going to do here is I'm just going to show you when it is impossible to find the height, there's something else you can do. If we're looking at C, so if this is our angle over here, what is the ratio for sine of C in this triangle? What letter goes over what letter? Remember, sine is so O over H. We have to look at a right triangle. Always when using trig, we look at a right triangle. So this C is in this right triangle. What's our O and what's our H? Yes, sine of C is H over A, right? This is our opposite side, this is our hypotenuse. Now, we know it's impossible to find H. So what we want to know is, okay, what does H equal in terms of this formula? How would we get H by itself? Exactly. To get something out of the denominator, you multiply both sides by the denominator. So when we multiply both sides by A, the A's cancel on the right and you're left with just H. So H is by itself. H equals A times sine of C. In other words, in this 1/2 times base, but instead of writing height, we're going to write this function, A times sine of C. This is used when you do not or cannot find the height because A times sine of C will give you the height. Now, the only trick to this formula is that you can only use this formula when you have a side angle side triangle. Whoops. So if we look at this first example, we're given a side, we're given a side, and we're given this angle. So this is a side angle side triangle. I'm good to go to use this formula. The formula is area equals 1/2. Uh, I'm just going to flip these two letters because normally A is written first. It does not matter. What those A and B are referring to are the two side lengths that get you. And then sine of C, what that C is referring to is the angle between them. So here, this, whoops, this is our A, this is our B. It doesn't matter which is which. All that matters is that the angle is between them. So I do 1/2. Again, does not matter what order you put the side lengths. And then sine of the angle it gives you, the angle that is between the sides. And then you just plug this into your calculator. And you get 85.00, and you're done. That is the area. Now, is this the completely correct answer? Would you get full credit if you just put this, if we were in school? Yes. Area always has units squared. It is two-dimensional. Area is two-dimensional. It's on the x-axis and the y-axis. So it has to be units squared. Any questions on this type of problem? Thumbs up if you could do this on your own. Thumbs down if you would like one more quick example. Okay, I'll give you 5 people. Remember, if you're ever confused by anything, I do have the complete key, and I'll remember to put it in the 10th class too this time. I'm so sorry. But I do have the complete key for this link on Schoology, so you can go back and look at another example. Really, all it is taking your two sides, multiplying them by 1/2, and then multiplying it by sine of the angle between, and plugging in your calculator, and you're done. So that's what that second problem would be. The equation of 1/2 times 25 times 21 times sine of 24. Now, notice in number 3 and then 4, these are not side angles, side triangles, meaning we cannot just straight use this formula. Instead, what we're going to learn in the next 2 class periods, law of sines and law of cosines, is going to help us solve for these so that we can then eventually use our formula. So don't worry about 3 and 4. Those types of problems will not be on your homework for tonight. They're not on structure, and 5 won't be on your homework either. 6 will be, but 6 will be, nope. I do not believe that we're gonna, I know there are examples on here, but I do not believe that we're going to make you find area of a triangle that isn't either side angle side or what we're about to learn, side 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 triangle. Now this is the formula that I was talking about that in my head really doesn't make sense why it's in unit because it has no trig at all in it. This Heron's formula. But I get it. We're finding we're trying to find area, and we just found area, so we're like, okay, keep doing area. Heron's formula you use when you have a side triangle. So you use the previous formula when you have a side angle side. Now this is the formula you use when you have 3 sides on a triangle and you're trying to find the area. You use something that's called Heron's formula. This formula states that you can find area. Oh gosh, that's a great square root, isn't it? When you have the square root of a little s, which this little s we're about to go over in a second is called the semi-perimeter. So little s times the semi-perimeter minus the first side times the semi-perimeter minus the second side times the semi-perimeter minus the third side. A, B, and C are the side lengths of the triangle. Now, that semi-perimeter is actually really, really easy to find. It's just hard to memorize how to find it. But because we're virtual, you don't have to memorize anything. So the semi-perimeter is the 3 side lengths added together divided by 2. It's always 2. Always, always. It's never 3. It's not because there are 3 sides divided by 3. It's not the average perimeter. It's the semi-perimeter. So you're always dividing by 2. So let's try it real quick. We got 3 minutes. We can do it. Here we have 3 sides on a triangle, a side-side-side triangle, meaning I need to use Brown's formula to find the area. First thing is to find the semi-perimeter. You do this by taking the 3 sides added together and you divide them by 2. So that's going to be 18 plus 21 plus 19 divided by 2. Now that we have the semi-perimeter, to find area using Heron's formula is really straightforward. It is just the square root of the semi-perimeter times the semi-perimeter minus the first side times the semi-perimeter minus the second side times the semi-perimeter minus the third side. Ooh, that really screwed up. I wish there was a back arrow on this application. So it's 29 times 29 minus 18 times 29 minus 21 times 29 minus 18. And all you do is take this big old thing and you put it in your calculator. Oh, no. So you do the square root of 29, times 29 minus 18 times 29 minus 21 times 29 minus 19, and you get 159.75. And our unit is miles, and we always square our area units. And we're done.